Welcome back to this video series of C++ programming. This is the lecture 12 of this video series, and today we are going to talk about array of objects and object pointer in C++. Let's discuss about the array of objects first. Array of object is similar to creating an array. So how do we create? Specify the name of array. Before that we specify the type of that array, name of array, and then the square brackets. So similar to that, we can create the object array. So syntax of object array is same as that of array. The object can be initialized by defining the values within array elements. So similar to array, you can define the values within the object array, and that will act as initialization values. So when you create this object array and specify the values, internally a constructor is called. So that is a parameterized constructor, and then those values can be used to initialize the data member. We'll talk about these 2 points with an example. First, we'll create one class, call this as a my class, and inside this we'll create some private data members, say integer value, and then we'll create some public members. Now this is one class, so inside this main function I'll create an object, or rather I will create array of objects. So as we saw, to create an array of objects you have to specify the name of object, then these two square brackets, and inside this the number of elements or the number of objects you want to create. So in this case, the three objects will be created, or this is an array of three objects, and the type of this array is this my class. Now with this objects we can access this members. So we can access the public members from this main function using this object array of objects. So let's see how. First we'll set the values to this data member value, and then we'll print those values using this get value function. For that I'll create another variable, say it I. Here we'll use a for loop. Now observe it carefully how we call the set value function. So we have specified the name of object, and then inside square bracket we have specified the index. So here I is the 0th index, so we are referring to object of 0. When you create array, this is basically it starts from the 0. So when you specify the 3 is the size of this array, so the indexes will be 0, 1 and 2. So here we are using this I as an index, so initially it will be 0, and we need to set the value. So I will pass the value as I plus 1. Now this loop will iterate 3 times and it will set the value. We'll call this function set value, and inside this it will assign uh, this passed value p to this data member value. Now since this is array of objects, we have created the three objects. For each object a separate copy of this variable or member variable will be created. Here I have written a similar statement, so which will take the values or the value of this data member variable value using this get value function, and we'll print this value out of the console window. Alright, so now let's compile the code and let's see what does it outputs. It is outputting the values as 1, 2 and 3. Why? Because we are passing this, here we are setting the value as the index and then plus. So once it is first time it is 0, then we are incrementing by 1 or adding 1 to it, so it will become 1. Next time 2 and 3. So that's why it is output as a 1, 2 and 3. We saw how we can create an array of objects, and with that how we can access the different elements of that array of object. When you create an object, we can initialize the object elements at the same place, so that is in place initialization. Here we need to call when you initialize the value of the data members, we have to specifically call this set value function. So with the help of this object in place initialization, we can eliminate this additional function. And when we do this, we have to create a one parameterized construction that will take those values. First, see how we can initialize the values to array of objects. So similar to array, we have to specify the this equal to operator and then this two curly brackets. Inside this, we'll specify the values. So in this case, when you create this object, as soon as you create a constructor function will be called, and inside it will take those values, and then we can assign those values to this public member value. So for that purpose, I would create one constructor function here. So how to create constructor function is to specify the name of that constructor function, which is name of that class, and then we are passing some value, so we have to make it as a parameterized construction. So now let's compile a program and let's see now what does it output. So now also it is outputting the 1, 2 and 3. So we have in place initialized this object with the values 1, 2 and 3, and that's why it is outputting the values as 1, 2 and 3. So this is how the initialization objects can be done. Now this initialization is equivalent to a statement which I'm going to write here. So now this both the statements are same, but this is a shorthand notation, shorthand form, and this is a longhand form of initialization or object array initialization. Both serve the same purpose, but one is a short form and another is a long form of initialization. Now this long form of initialization is very useful if you are passing the more than one values in this object. So here we are passing just one value, and that is we are collecting in this constructor function here. But what if we specify the two values or more than the one values? Then we cannot use this initialization format. So we have to use this long for initialization format. So let's see how we can do that. So here I will create another variable q, and so we are passing the two values. We have to modify this statement. So it is very simple. We have to use the same syntax, but now we are passing the two values, so we have to specify another value here. Similarly, because for every object we are passing, your compiler is expecting the two values. So we have to pass the two values. We saw how we can initialize the array of objects when with the more than one value. One last point, and that is about the initialized and non-initialized array. So in this case, this in both the cases, the array is initialized. So suppose you have created another array of objects, and I'll call this as object 3 or object 2, and we'll specify size as 3. Now in this case, this is a non-initialized array object. We're not initializing any value to this object. Now in this case, the compiler will show some error. So uh, it will throw an error saying no default constructor exists for class my class. Why this is so? In this case, as you know, when you create an object, by default the compiler will create one constructor for you. So that is a default constructor. And when you create your own compiler, that default constructor gets override. So in this case, when you have created this object 3 and initialize some values to it, we have created another constructor, which is a parameterized constructor. And when we do this, this new constructor overrides the default constructor created by compiler. And when you create this another object, which is uninitialized object, then the compiler finds there is a no default constructor because it is overridden by another parameterized constructor that you have created. And that's why it is showing the error saying there is a no default constructor exists for this object too. we have to create then another constructor, and this is called as a constructor overloading. So it is concept of function overloading. And inside this, then you don't have to specify any parameters. So since it's a parameterless constructor, and when you do this, now this object 2 is resolved. Now compiler is not showing any error to this object 2. So this is how this uninitialized object array and initialized object array is created. Now we'll talk about a pointer to objects in C++. Similar to a variable, the pointers can be used with the objects as well. And when you do that, you have to use this arrow operator to access the class members instead of dot operator. And the third very important point, if pointer is pointing to an array of objects, pointer increment operator can be used to access the members of objects for a particular class. So similar to a pointer variable, this increment arithmetic operation can be performed with the object pointers. We'll talk about all these 3 points with help of example. Finally, the address of public member of object can be assigned to a pointer. So we'll talk about this fourth point as well. So here, first we'll understand how we can create an object pointer. So we have seen in the lecture 4 of structures how we can create a normal pointer to a variable, and then we saw how we can create a pointer to a structure. So similarly, we can create a pointer to an object. So to create a pointer, you have to specify this name of the class, which is a data type, and then pointer. So it is called as a p object, so which is a pointer to an object. Now with this pointer object, we can access the different members of the class. So for example, now we have created this p object pointer, and to access the members, we have to specify this arrow operator, and then we can access these public members from this main function using this object pointer. But before accessing, we have to initialize this object pointer, because by default it is not pointing to any memory location, and when you try to access the public members without assigning any address to this pointer, then it will result into an incorrect operation, so your system might get crashed. We have to initialize, so I will create another object in this case, and I will call this as object 3, and specify the address of this object 3 to this p object pointer. Now this is pointing to this p object 3. So this p object pointer is pointing to this object 3. So this ampersand operator acts as an address of this object 3. Now we can access the member functions using this object pointer. So first I will use this set value function to set the value, and I will call then a get value function. Here we pass the value as say 50. Now let's compile the program and let's see what does it output. So it is outputting the value as 50. So 50 is the value we have initialized. We're setting here using this object pointer. So we saw how we can create a pointer to an object and how we can access the different elements using that pointer. Pointer operations are very useful when you're passing the pointers or passing any variable to the function, because as we have seen earlier, when you pass the any objects to a function or any variable to that function, the separate copy or new copy of that object is created, and that object is stored onto a stack, the temporary memory. So if you're passing the objects which is of a larger size, every time a new object will be created and a lot of memory on the stack is wasted. Definitely that memory is destroyed when you exit that function, but if you're pushing a lot of data onto a stack, then there might be a possibility of getting stack overflow. So it is better to pass the pointer to a function instead of a direct variable. So in that scenario, though, object pointers are very useful. We'll also see how we can use this array of objects using this pointer. So here I will assign this p object pointer with this base address of this object. So this object is nothing but the array of objects. And so whenever I spacing this name of this object, it's actually referring to the base address of this array object array. In this case, this is the base address or the starting address of this array object. So you don't have to specify this address operator. Just simply specifying the name of object will point to the base address. And now with this object pointer, we can set the different elements of this object. So I will use this for loop here. So what we have done here is we have created this object pointer and we have assigned this base address of this array of objects to this p object pointer. And now with the help of this object pointer, we are calling this set value function and we are assigning this pass value to a member variable. So when you call this, when you use this p object variable, we have to use this arrow operator to access the members of the class. Similarly here, to get the value, you have to specify this same syntax, the name of this pointer variable and this arrow operator. Now let's compile the program and let's see what does it outputs. To your surprise, now it is outputting the value as 3. So all these values are 3. You are expecting value to be 1, 2 and 3. So why it is outputting the value 3? Reason is here this p object is assigned with the base address of this array of objects. Right? And when we use this operation or when we call this function, every time it will point to the same memory location. So it will every time it will point to this base address because we are not incrementing this p object. We must go to the next address and then assign the value in that location. But we are not doing that. So what we have to do is we have to increment this p object. So that's a pointer arithmetic operation we are performing. And as we have talked earlier, all the pointer arithmetic operations are related to its base address. So when you increment, it will point to the next data of the next variable of the data type. So in this case, data type is this class. So when you increment this pointer object, it will point to the next object of that class. So in this case, these are 3 objects are there. So it will point to the next object. So it will point to this memory location, which is of object 1. This is object 0, this is 1, and this is object 2. So in this location, it will set the value. Here also, when we are getting the value, we have to increment the object. However, one more problem here is we have incremented this p object here. So after every loop iteration, we are incrementing this p object. When we come here, it will point to the 4th element of that p object. So we have incremented the thrice, and it will again next time it will point to the next object, which is actually not existing. So it will point to some another memory location in your memory, and that's why it will print some garbage values. To avoid that, you have to again reinitialize this p object to the base address. So what is the base address? Is this object 2. So we are reinitializing it to the base object. Now it will again point to the start of this object array. So now let's compile the program and let's see what does it outputs. So now it is outputting the values correctly 1, 2 and 3. So this is how we can use the object pointers to point them to an array of objects. Now we'll see how we can pass the object pointer to a function and how to return the object pointer from a function. This is similar to what we discussed in the lecture of structures. First, we'll see how we can pass the objects to a function, object pointer to a function. So I created this another object called as object3, and here I will create another function. Say data, and inside this we'll create a temporary pointer, a temporary object pointer. So how to create? We have to specify the type of that object, that is my class, and then the object pointer. So I call this as a ptemp. We call this function set data function from using this object3. So how to call that function is since this is object, so we have to use the dot operator and this function. Here we have to pass the address of this object, in this case address of the object3. So it will be collected as object pointer in this ptemp variable. And now with this ptemp variable we can use this ptemp variable to access the member variables of this class. This is how the object pointers can be passed to a function. Similarly, the object's pointer can be returned from a function. For that purpose, I will create another function that will call this as a display data. And inside this, we have to return the address of the objects, and that can be collected as a pointer in another function. For that purpose, we have to create a object, and then we can return the address of this object. So I will make this as a static so that it doesn't remain on the stack. And here I have to specify the type. So return type is the name of that class, which is my class. Here we are returning the address of this object. And now inside this, we'll collect this return address into another variable. But now what should be that variable? So we are returning the address, we must collect that into a variable of a pointer. So we have to create here a variable, this object pointer. We'll call this as a p object. And now inside this p object, we can get the address of this temporary objects, or rather the objects present in this display data function. We have to call this display data function. So with the help of this object3, I will call this display data function. And we are collecting that address into this p object. One point we forgot here, when you specify the return type, this time you have to specify the pointer as a return type, because we are collecting that into a pointer variable. We saw now how we can pass a pointer, object pointer to a function, and how we can return the object pointer to a function. Let's discuss about this fourth point. It says the address of public member of object can be assigned to a pointer. That means here we'll create one public data member, and we'll call this as a data1. Now so this member is a public, so it can be accessed outside this class. And what at that point says, we can uh, assign the address of this public data member to another pointer variable. Now this member is of integer type, so we can only use the integer pointer to assign the address of that integer variable. So we'll create here another pointer called as integer p. Here inside this we can assign the address of that element. So for that purpose, we have to use this object and then dot operator and then the name of that variable. Now this p is pointing to this integer variable data1. Alright, and now this is called as a referencing, and to print the value of this data1 element using this pointer is by using the dereferencing. When you say asterisk p, this is actually dereferencing the pointer. So we are printing the value of data1 using this dereferencing. I hope now we have covered all the topics related with the array of objects and object pointers in this video. So more about the pointers or the object pointers we'll discuss when we talk about the advanced topics of C++ programming, where we'll talk about the inheritance, where we'll use the derived classes, and in that derived classes, we'll see how we can use the pointer with the base classes and the derived classes. For now, thanks for watching this video and stay tuned for the upcoming video.